In graph 11.6 we found two ways of illustrating the change in behavior that emerges when the wage changes for a profit-maximizing producer. We can now do the same for changes in prices. We begin again with our usual production constraint, as well as an initial price of 5 and wage of 20 that results in the profit-maximizing production plan A, where we use 78 labor hours to produce 354 units of output. Next, suppose that the price rises from 5 to 10, which means the isoprofit lines will become shallower, which further implies that the highest possible isoprofit line will be tangent to the production frontier on its shallower portion, in our case at production plan B. Notice that this graph looks exactly identical to panel A of graph 11.6, where instead of the price increasing, the wage fell. The reason for this is that in both cases, the isoprofit lines become shallower. They start for us with a slope of 4 because the initial wage is 20 and the initial price is 5. When the price increases to 10, the slope becomes 2, 20 divided by 10. If the wage instead fell to 10, the slope would also become 2, 10 divided by 5. Thus, whether the wage falls from 20 to 10 or the price increases from 5 to 10, we end up at the same profit-maximizing production plan B after the price change happens. Next, we can see how this plays out on the graph with the marginal revenue product curve instead. So we begin on the lower graph by illustrating the marginal revenue product curve when the price is equal to 5. Before anything changes, the wage is 20, and we therefore choose A prime on the marginal revenue product curve, hiring 78 workers, just as we did in the production plan A in the top part of the graph. Again, this means that we actually lose money for the first 22 worker hours that we hire, but then we make money on the next 56 hours until we get to 78 worker hours. We wouldn't want to hire beyond that because the marginal revenue product falls below the wage after 78 worker hours. And the green area is larger than the magenta area, indicating that overall we're making a profit, just as the positive intercept of the blue isoprofit line in the top part of the graph indicates. When price increases to 10, it scales up the marginal revenue product curve, because marginal revenue product is price times marginal product. We therefore get the new magenta marginal revenue product that corresponds to an output price of 10, and given that the wage doesn't change and remains at 20, we can go over and read how much labor we're going to hire off of point B prime, which in turn corresponds to the production plan B, which we concluded was profit maximizing once the price has increased, in the top part of the graph. Since we concluded that an increase in the output price from 5 to 10 causes the same change in behavior for the producer as a decrease in the wage from 20 to 10, we can also see in this graph that if we lowered the wage to 10 instead and remained on the original marginal revenue product curve that corresponds to an output price of 5, we would end up hiring the same number of workers as we do at B prime. In both cases, we end up hiring 90 workers, because in both cases, the profit-maximizing production plan ends up being production plan B in the top part of the graph. We can see again that we initially lose money on the first worker hours that we hire, up to 10, but then for the next 80 worker hours, we make money. This results in a relatively large positive green area and a relatively small negative magenta area, giving us an overall positive profit, just as the positive intercept of the magenta isoprofit line that's tangent at the production plan B indicates in the top part of the graph. We can furthermore calculate what exactly the profit is by knowing that the intercept in the top graph is 209. Profit divided by price has to be equal to 209, and price is now 10. So when we multiply both sides by 10, we get that profit is equal to 2,090. Thus, the green area minus the magenta area in the lower graph is equal to $2,090. When we develop the top portion of the graph, we noted that it looks exactly identical to the top portion of panel A of graph 11.6. In 11.6, we lowered the wage from 20 to 10, whereas here we increased the price from 5 to 10. In both cases, the isoprofit lines change in exactly the same way, in the sense that they end up with the same slope, and therefore the new profit-maximizing production plan ends up being the same. Thus, the behavioral change that we observe as a result of an increase in the price from 5 to 10 is exactly identical to the behavioral change we observe from a decrease in the wage from 20 to 10. But not everything is identical, as we can see in the lower panels that look very different. In the case of a price increase, the labor demand curve therefore shifts out, causing us to increase the number of workers we hire. In the case of a decrease in the wage, on the other hand, the labor demand curve does not shift, but we move down the labor demand curve and again hire more workers. While the change in behavior that we observe is therefore the same, the implications for profit are not. You can see that by again looking at what that intercept in the top graph means, where we have profit divided by price is equal to 209. When price goes to 10, this implies that profit is $2,090. When the price stays at 5, it means that profit is $1,045, only half as much. Thus, even though a wage decrease from 20 to 10 causes the producer to behave in exactly the same way as a price increase from 5 to 10, the producer would much prefer to have the price increase rather than have the wage fall.